Welcome, my name is Brian Nelson. This is the 5th lesson in the Introduction to Programming with C# course. In this lesson, we're going to introduce looping data structures. Let's get started. Looping data structures are useful for situations where you want to execute a block of code a number of times. As an example of this, you may want to simulate rolling a 6-sided die 3 times. Another example is if you had an array with the hourly temperatures for a day, and you wish to calculate the day's average temperature. You would loop through each element in the array and sum the values. Once the loop was complete, you would divide by 24 hours and have the day's average temperature. The first loop structure we're going to discuss is the for loop. The for loop lets you execute a block of code a specific number of times. When you define the for loop, you define a counter, you specify the conditions that the loop completes, and you define how the counter increments. Let's take a look at how to set up a for loop now in Visual Studio. Let's set up a new console app for lesson 5. So let's get rid of this, and we have a clean project. We're going to look at a for loop now. I'm going to type up the definition of a simple for loop, and we're going to count from 0 to 9. Let's define that. So for int I equals 0, I is less than 10, and I plus plus. What does plus plus do? We haven't seen that. So if we take a look at this, we're going to declare j equals 0 and then j plus plus. So let's just go ahead and run that. It's easiest to show. And I'm going to hit F10. So j equals 0, j plus plus equals 1. So what does it do? It's the same as if we were to say j equals j plus 1. It'd be the exact same thing. Now we can see that. J equals 1. Now j equals 2. It's just a shorthand notation for doing j equals j plus 1. While we're at this, we can take a look at j plus equals 3. And so that's the same as j equals j plus 3. So that's another shorthand, and we can see that. So let's go ahead and have a look at that. So at this point it's 3, and now it's 6. You could also do j minus minus to subtract 1, which is the same as j equals j minus 1. Or you could say j minus equals 4 to do j equals j minus 4. Those are all the same. Anyway, that's just a quick example of what the plus plus, minus minus, plus equals, and minus equals can do for you. So let's get back to the for loop. So what we're saying here is for I equals 0, we're going to start at 0, and we're going to go while I is less than 10. And then for each loop, we're going to say I equals I plus 1. What we're going to do now is we're going to just call double sum equals 0. We're going to just add up those first things. Like we just learned, we're going to do sum plus equals I, which is equivalent to sum equals sum plus I. Okay, so these are the equivalent statements, and we'll just go with the shorthand one. And I'll just comment this out for a note. Let's just write that out. Console.write line. We're going to write the sum. Okay, so this will sum 0 plus 1 plus 2 plus 3, so on through 9. Let's just hit F5, and we'll go to our breakpoint, which is on that definition. All right, and so sum 0 plus 0 is 0. And now we're at I equals 1, so we should get a value of 1. And now we're at the value I of 2, so we should have 1 plus 2 is 3. Okay, and we're going to just continue on to the console. Adding the values from 0 to 9, we end up with a value of 45. So we'll just do that, and we can look at our output, and we have a value of 45. That's a pretty basic structure for a for loop. Now, you don't have to start at 0. You can start at any place along this loop that you'd like. Let's take a look at that. So we're starting now from 5 while I is less than 10. And for each step, we're going to go 1. So let's hit F5, and we're going to hit our breakpoint. You can watch. So I is now 5. We're less than 10. So that's great. So 0 plus 5. All right. And so we have a value of 5. And now we're going to add 6. 0 plus 6 is for 11. And so let's continue on. So now you can see the sum is 35. Okay, great. So let's set it back to 0. You don't have to just go by 1. You can go by 2s. So now we'll go from 0 to 2 to 4 to 6 to 8, 5, and then we're going to F10. So we start off at 0, fine. Sum of 0. Now our value is 2. Okay, so great. So now we're going in steps of 2. So now we get a total of 20. That's great. So you can do any steps that you'd like. Anyway, so those are just the different parameters you can play with, and you can change the condition. We can say, okay, let's step by 1, but let's only go to 5, from 0 to 5. And so we can do that. Our last value will be 4 because it's less than. And so now we have a sum of 10. You can also do a less than or equal to in this case. So we should end up probably with a value of 15. So let's see where we go. We'll hit F5 to continue. And so now we have a value of 15 as we expect. So that's the basic structure of a for loop. And just to reiterate, it's good for looping when you have a known number of steps. A good place to use this if you need to go through each element of array. If you have a 5-cell array, you can go from 0 to the 4th to 0, 1, 2, 3, 4, 5 elements, because they all start with 0. You can loop through that entire array very quickly. So let's actually do an example with going through an array. So if we say double values, and that's going to equal new array with values of 3.0, 6.0, 9.0, 12.0, 15.0. To say those are our values, and I need to say it's going to be an array. Good, so that's happy. But now we're going to sum values, and we're going to say I. This is the 0, 1, 2, 3, 4, so we want to go less than 5. So let's see how that works. So we get a sum of 45. Now let me show you one other trick while we're here. We can say values.length. And so what this lets us do is, rather than have to count them, if we were to add another 18.0, it would automatically, and let's go ahead and run, values.length is 6. And we'll get into properties of objects later, but this is a property of the object. It's how many elements are in that array. And so this just lets us define a loop without having to always count them and make sure. This verifies that it will always be the right number of elements. And if we see now and we go to the end, we have a value of 63. So 45 plus 18, 63. The second type of loop is the while loop. The while loop continues executing a block of code while a Boolean condition evaluates to true. The check is at the beginning, so the block of code will only be run if the condition evaluates to true. Let's set up the while loop in Visual Studio. I'm going to comment this out, and we're going to take a look at the next loop, which is a while loop. We're going to come down here, and we're going to say a while loop. First of all, let's define a condition, and we're going to say bool done equal false. And then we're going to say while not done, and the exclamation point is the not operator. And then what that does is say it's the opposite. So if done is false, this will be true. If done is true, this will be false. So while true, we are going to do something. Let's do something similar to our counter. Int count, and we're going to say count equals 0. And I commented that out, so let's uncomment that out. So what we're going to say is sum plus equals count. So we're going to just do the same kind of thing. But what we're going to say here is count plus equals 3. So we're going to step in increments of 3. And then what we're going to say is if count is greater than 10, we're going to say done equal true. And now down here, we're going to just write out our sum. Console.writeLine sum. Let's go ahead and try this once. So I'm going to hit F10, define sum. Okay, we're false on done. We're count is 0. And so false and then not false is true. So we add 0. Okay, is our count, okay, it's not greater than 10. So we're going to add 3 to it. And we're going to do it again. So now our sum is 3. Okay, now our count, we're up to 6. And so now we're still, so in this case, our count is now up to 12. We add 12, and now we've decided we're done. And we write out our total for 30. We can also do this a little different. So what we could also do is say we don't want to write it this way. Let me copy, and I'll comment. Okay, so we're going to paste that. So here's where we're at now. Now what you notice is I've incremented the count down at the bottom, but our test is in between the summing. And what I want to show you is that we can move this out to here. So what I'm going to change this is less than or equal to 12. Because the way I wrote it, it would add 3 after we've done the sum. So, but now we can get rid of this. Okay, put a breakpoint here so we can hit F5. So our count is currently 0, and I'm going to just let it go till we get to that. And our sum is 30. It stopped when the count went above 12. So that's another way that we can write this. This loop is more flexible from the point of view that it can be any arbitrary condition. It can be anything that amounts to a Boolean, where the prior test was really focused on that integer and how it incremented. This is a much more flexible structure. Let's set our count to 13 at the beginning. Okay, so we're going to start with 13, and let's restart this. So what you'll notice now is 13 is not less than 12. So we don't even go through this loop once. This block of code never executes. The while loop does the check at the beginning. And so as we get into the next loop, we'll see an alternate structure to this.
The third type of loop is a do-while loop. The do-while loop is similar to the while loop, except that it tests the condition at the end. This means the body of the loop executes at least one time. Now we will set up the do-while loop in Visual Studio.
Instead of a while loop, we're going to do, and then what happens here is while count is less than 12. Okay, and so what that lets us do is we're going to get sum plus equals, and we'll do the count plus equals 3. And let's start this back at 0. Let's put a breakpoint right there, and we run to that breakpoint with F5. So we go through same way as it would before, and we get a sum of 18. The trick here is, and this is less than 12 the way I currently ran it. Let's go back to our 13 example where we're greater than our test. And what we see is, when we rerun it, the loop fires the first time no matter what and writes out the value of 13. So In a do-while loop, you are guaranteed that it will execute at least one time. With the while loop, it depended on how the Boolean test worked out. So if the Boolean test was true, it would go. If it was false, it would never fire that block of code. They're very similar structures. It's just one allows the loop to always run once, and the other, it's conditional at the beginning. There is one additional type of loop which is very useful when you have a collection of objects. This is the for each loop. I'm going to hold off discussing this type of loop until the foundation of collections has been introduced. This will happen in the next course. This wraps up the 5th lesson. In our next lesson, we will introduce classes.